Hello students, how are you all? I hope you are doing absolutely good. So welcome all of you at AriserTalent, and today we are going to deal with some of the questions from your chapter electricity that are from your NCERT. So let's begin with the questions here. Several electrical bulbs designed to be used on 220 volt electric supply. It means you are provided with the voltage here. So firstly, let us write the given conditions here. Voltage V equal to 220 volt. Now, electric supply line are rated 10 volt. 10 volt is rating, so watt is a unit for power. So you had also provided with a condition, that is power. So the power in the question given is power P equal to 10 watt. Now, how many lamps are connected in parallel with each other across the two wires of 220 volt that the maximum current is 5 ampere. So you have to calculate again the number of lamps. So what I have to determine here, we have to determine the number of lamp, and we are also provided with the value of current, and the value of the current here is 5 ampere. So this is the given condition here. Now, power, voltage and current is given. So again here we have to apply the formula for power, and the formula for power is V square R. So firstly what we will do, we will calculate the value of resistance here. So from Ohm's law, R equal to V upon I, this is our Ohm's law. Voltage here is 220 volt and the current is 5 ampere. So it came out to be 44. It came out to be 44 ohm here. So this is the resistance here. Now, we have to calculate the number of lamps, and you also have to know that these lamps are connected in parallel. So if I am assuming that the number of lamps that are connected in parallel here have a resistance R1, let R1 be the resistance of these lamps. So if they are connected in parallel, then R1 came out to be N upon R. This is the number of lamps we are obtaining here. Now, again power will having a formula, that is V square upon R. This is a formula for power we have, and R can be calculated as, power will be I square R and V square upon R. Power will be I square R or V square upon R. So we will use this formula here. So P equal to V square upon R. If I am going to calculate R, it came out to be V square upon P. Value of voltage is 220. And what is the power in this case? Power in this case is 10. So 220 into 220 upon 10. 1 0 must be cancelled by 1 0, and what we will get here? We will get here 4840 here. This is the resistance here. Now, this resistance we have calculated here is our R, that is for the power, and here we have calculated the resistance as R1. Now what I have to determine here, I have to determine the number of lamps that are connected in parallel. So the number of lamps will be R upon R1, because here we are getting 1 upon R1. This combination is again in parallel here. This is our 1 upon R1. So number of lamps will be, total resistance is 4840 and the resistance we are getting here is 44. So it can be equal to 110. So how many lamps you have to connect it in parallel? You have to connect 110 lamps to get the power 10 volt and current is 5 ampere. So the value of N equal to 110. So we are needed 110 lamps. So I am again repeating here what we have done in this question. We have to find out the number of lamps in parallel. So firstly we have defined a resistance from the Ohm's law and it came out to be 44 ohm. Now from the formula of power we have again calculated the total resistance of the system, that came out to be 4840 ohm. Now these resistances are connected in parallel. So for the parallel combination we have a formula 1 upon R equal to N upon R here. So on applying this formula, if I am substituting the value of R1 and R, we will get the number of lamps here, that came out to be 110. So the 110 lamps are needed for getting the allowable current in the circuit, that is 5 ampere. So this is the solution of this problem. Let's copy this solution from here. Now let's move to the next question in this sequence we have. A hot plate of electrical oven is connected to a 220 volt battery, has the two resistances of 24 ohm and 24 ohm separately. You have to connect this system in series and parallel and you have to find out the current in all the three cases. Now what you will do in this question, you have the three parts, one is the simple case, one is the combination in series and one is the combination in parallel we have. So what we will do here, first write the given conditions. What are the given conditions here? You have provided with a voltage of 220 volt. Then after you have two resistances, R1 equal to 24 ohm and R2 equal to again 24 ohm. Okay. Then we have to calculate the current in the series, parallel as well as the individual combination. So firstly I am finding the current in the simple combination. For the simple combination, I will again apply the Ohm's law. So you can see here that how Ohm's law is important in this case. Ohm's law equal to V equal to IR. This is the Ohm's law we have. If I want to determine the value of current, I will get I equal to V upon R, that is equal to 220 upon 24. On solving this numerical, we will get 110, 12, 55 and 6, and 55 upon 6 will be almost equal to 6 8 are 48, no 6 9 are 54, almost equal to 9.1 ampere. So this is the simple case we have. This is our case 1. Now let's move to the case 2. In case 2, you have to connect both these resistances in series. So we are connecting the resistance in series. Resistance in series. Now the resistance in series will be Rs and that will be equal to R1 plus R2, and the value of R1 is 24 and R2 is again 24 and I am getting here 48 ohm. This is the 48 ohm, the total resistance we are getting in the circuit. Now again I equal to V upon R, voltage 220, and here instead of using R I am using the term Rs upon 48. Now again solving this equation, 110, 24, 55 and 12. And 55 upon 12 will give you approximate value, 12 4 are 48, 7 is left and 12 5 are 60. So this is what I am getting here, that is equal to 4.5 ampere approximately. This is the value of current in our second case. Now what is the third case saying? Connect these resistances in parallel. So our case third will be resistances are connected in parallel. If these resistances are connected in parallel, what will be the value of the equivalent resistance here? The equivalent resistance will be 1 upon Rp, and it came out to be 1 upon R1 plus 1 upon R2. So now 1 upon R1 plus 1 upon R2 will give you 1 upon 24 plus 1 upon 24, and it will give you 2 upon 24 here. Now the value of Rp will be 24 upon 2, and it came out to be 12 ohm. So the resistance I am getting here is 12 ohm, but I have to determine the value of current. So we will determine the value of current here. So just look at here. I equal to V upon R. Voltage is 220 and resistance here is Rp, that is equal to 12 ohm. This is 6, this is 110, this is 3, and this is 55. So 3 1 are 3, 3 8 are 24. It is approximately 18.3 ampere. So this is the value of current in the parallel combination we have. So here we are getting the 3 answers: 9.1 ampere in the simple case, 4.5 ampere in the series case when the resistance is Rs. So I can call it as Is. This is our Is, and this is the current in our parallel combination. So this is again a simple formula which is based on the Ohm's law and the resistance in series and combination. So from these questions you can notice here that most of the questions in the exams are usually asked from Ohm's law and connection of the resistances we have. So just copy it from here so we can proceed to the next one. Now let's move to the next question in this sequence we have. Compare the power used in two resistors in each of the following circuit. So you have to compare the power in both these cases. So the first case I have given is a 6-volt battery in series with 1 and 2 ohm resistor. So let us write the given conditions here. Given is 6-volt battery. 6-volt battery, 2 resistors are given, 1 ohm and R2 equal to 2 ohm. So this is this is our case 1. Now you have to compare the power in both the cases. So these two resistors are connected in series. If these resistors are connected in series, what I have to calculate? I have to calculate the equivalent resistance of both the resistors. So if I am going to calculate the value of Rs, it came out to be R1 plus R2, and it is equal to 1 plus 2, that is equal to 3 ohm. Is it all right? This is came to be a 3 ohm. Now what is the formula for power? The formula for power will be V square upon R, and in this case it is Rs because we are using the series combination here. Now the power will be calculated by V square upon R. V is 6. So it must be 6 square and it must be 3 ohm. So 6 into 6 upon 3, it came out to be 12, and what is the unit of power here? The unit of power here will be watt. So this is our case 1. Now let's discuss the given conditions of case 2. Let us read the question first. 4-volt battery is connected in parallel with 12 and 2 ohm resistors here. So the battery is of 4 volt. So I can write here V value will be 4 volt. The resistance R1 is 12 ohm and the value of resistance R2 is 2 ohm. Now The combination is in parallel, so again I have to find the value of equivalent resistance, that is Rp, and it came out to be 1 upon R1 plus 1 upon R2. Now on substituting these values here, what I am getting here, 1 upon 12 plus 1 upon 2, LCM will be 12, it came out to be 1 plus 6, 1 plus 6, 7 upon 12, and the value of Rp equal to 12 upon 7. And this 12 upon 7 came out to be 7 1 are 7, 7 7 are 49, equal to 1.7 ohm approximately. Now again calculate the power in this case. So again applying the formula of power, what we will get, V square upon Rp here. Why I am using Rp? Because it is a combination of parallel resistances we have. Voltage here is 4 volt. So it means 4 square upon 1.7. It came out to be 4 into 4 upon 1.7. So it is equal to 16 upon 1.7. Point must be shifted here. So it came out to be 9.1 ampere. Approximately 9.1 ampere, 9.1 watt we are getting here. So it must be equal to approximately 9.3 volt. So you can see that we will do the comparison of power in both the cases when we are using two resistors. When you connected the resistors in series, the power came out to be 12 volt, but you have the different value of resistances here. When you connect these resistance with a 4 volt battery having a different resistances, the power came out to be 9 volt. So this is how you can calculate the formula. You can use the formula and calculate the power in both the cases. So you just have to keep in mind that the power having a two formulas. You can use both these formulas for the calculation of the power here. So just copy this solution from here. Now let's move to the next question in this sequence we have. Two lamps, one rated 100 volt and 220 volt and the other is 60 volt and 220 volt are connected in parallel to the main supply. What current is drawn from the line if the supply voltage is 220 volt? Now first write again the given condition here. This is our lamp number 1 and this is our lamp number 2. Two lamps are given here. One rated 100 watt. 100 watt means it has a power of 100 watt. So the power is 100 watt here and the voltage is 220 volt. Now in the other case, power is 60 volt. Power is 60 volt and again the voltage rating is 220 volt here. Now what you want to know, you want to determine what current is drawn from the line if the supply voltage is 220 volt. You have to draw the value of current from here. So now from this equation, firstly you have to determine the resistances in both the cases because power and voltage is given. So again applying formula of power, what we will get, power is equal to V square upon R. So this power can be calculated as P1 equal to V square by R, and it came out to be 220 square upon 100. You have to determine the resistance in this case. So, the resistance came out to be V square upon P, that is equal to 220 square upon 100. Similarly, in the second case, you can see that R is equal to V square upon P, and it came out to be 220 square upon 60. Now, let us solve both these numeric values. 220 into 220 upon 100. 10 will be cancelled by 10, 10 will be cancelled by 10, and 22 into 22 will give you 484. This is the value of resistance we have. Now, let us check in the second case. The R came out to be 220 into 220 upon 60. 10 will be cancelled by 10, and what I am getting here, 220 into 22. So, it came out to be 4840 upon 6. On solving this, we are getting 6 8 are 48, 0, 6 6 are 36, 40, 6 5, 6 6 are 36 again, approximately equal to 806.6 ohm, and here we are getting 484 ohm. So, here we have calculated the resistances in both the cases. But what you want to determine, you have to determine the current drawn from the wire in this case. We have determined the value of voltage and resistance here and voltage and resistance here. So, simply by applying Ohm's law, you can determine the value of current, that is equal to V upon R in both the cases, and simply current can be calculated as I1 plus I2. So, this can be the solution of this problem. One shortcut method you can also use for solving this question. So, let us apply the shortcut method also here. So, what you will do, we will calculate the power by simply using the formula P equal to VI. Then I must be equal to power upon V. So, you can also apply this formula and calculate the power in this case. So, I am applying again the second formula for using the power. In first case, current came out to be 220 upon 100, that is equal to 2.2 ampere. In second case, it came out to be 220 upon 60. It came out to be 220 upon 60, and on solving this, what we are getting here, 3.66 ampere. So, the total current drawn from the wire will be I1 plus I2, and it is equal to 2.2 plus 3.66, and it came out to be approximately equal to 5.86 ampere. So, this is how you can use the simple second formula for solving this type of the problem. You didn't need to go for this method. You can also apply this method just by simply using P equal to VI. So, this is our alternative method for solving this question. Alternate method it is. So, just copy this solution from here so we can proceed to the next part. Now, the next question in this sequence we have which uses more energy, 250 watt TV or 1200 watt toaster. So, again this is very interesting question, that TV set will take more energy or toaster will consume more energy. So, again we are provided with the two cases, case 1 and case 2. In first case we are using TV. We are using TV in the first case, and in the second case we are using electric toaster. Now, TV is operated at a power of 250 watt in 1 hour. It means power and time is given here. So, the power is 250 watt and the time is 1 hour. For this 1 hour, I am converting it into the seconds, so I can write here 60 into 60 and it came out to be 3600 seconds. Now, our second part is we are using the toaster for 10 minutes. Toaster is having a power of 1200 watt. And what is the time toaster is using? Time here is 10 minutes. 10 minutes means 10 into 60, that is equal to 600 seconds. Now, you have to calculate which is using more energy. So, which apparatus or which electronic gadget is using more energy, we will determine by having a formula of work. Work will be the power into time and the amount of work done will just give you a value of energy here. So, energy will be calculated as power into time. Power is 240 and this is 3600 second. So, this is the energy we will obtain in the joule second. So, it came out to be 4 zeros will be substituted here, and on multiplying 36 into 25, what we will get here? 18, 2 6 are 12 and 7, 900. So, it came out to be 900 joule second. Now, our second part is, so it came out to be, we are using 250 watt, so there will be 1 zero less in this equation. So, what I am getting here? I am getting here 9 into 10 raised to the power 5 joule second. Now, let us move to the second case, that is of the toaster. Energy will be given as power into time. Power is 1200 watt and time is 600. So, it may came out as 12 6 are 72 and the 4 zeros. So, what is the value here? Value here is 72 into 10 raised to the power 4 and it is equal to 7.2 into 10 raised to the power 5 joule per second, joule second. So, what two answers are getting? You are getting in both the cases. In case of the television, you are getting the energy 9 into 10 raised to the power 5. And in that case, you are obtaining the energy 7.2 into 10 raised to the power 5. Then, which equipment is using more energy? It is very clear that TV is using more energy. So, TV at 250 watt in 1 hour will consume more energy. So, the answer here will be TV set will use more energy. So, this is again very interesting question here. Just copy this solution from here, so we can proceed to the last question of this sequence we have. Just copy this from here. Now, let us move to the last question we have. Now, you have to explain the following terms. So, this is our theoretical question which will be the reason based question from your chapter. But you have analyzed that mostly numerical type question can be asked from this chapter. Definition or simply unit type question will not be asked. Reason type questions are important from this chapter. Now, first question is, why is tungsten used almost exclusively for the filament of the electrical lamps? it means why we are using the tungsten for the filament lamp. In filament lamp, tungsten is having a very high melting point. So if it has a very high melting point, it will not melt easily and break the circuit. So the tungsten is generally used because it is having a very high melting point, approximately 3830 degrees Celsius. So the tungsten is used because it has high melting point. So this is the reason for our first solution. Second, why are the conductors of electrical devices like bread toaster, electric iron made of alloy rather than a pure metal? Now the question 2 is again very interesting question. You have seen that the devices which you are used in your kitchen like bread toaster, electric iron, these all are made up of the alloys rather than pure conductors. So these are generally made up of the alloys because alloys have higher value of resistivity as compared to the pure metal. So they will not melt very easily because they have the high resistivity. So the reason is alloys have high resistivity as compared to pure metals. So this is the third solution we have. Now the third question will be, why is the series arrangement not used for the domestic circuits? So the domestic circuits that we are generally using, we do not have a series combination there. We cannot use the series arrangement there because in series combination all the resistance are connected in one line. If any of the circuit will destroy or damage, the entire circuit will get destroyed and there will be the stoppage of current in that circuit. So generally series arrangement are not applicable for the domestic circuits we have. So the reason is, if one resistance in series get destroyed or will not work, the entire circuit will not work. Entire circuit will not work and current will not flow from the circuit. So this is the main reason that we are not using the series arrangement for the domestic circuits. Now the next question in this sequence we have, how does the resistance of a wire vary with the area of cross section? So this is the question from your factor dependence upon the resistance. So the factor on which the resistance depend is also area. So the fourth part will be, resistance will be inversely proportional to area. So how the resistance will be varied in the circuit? It means agar resistance will be increased, area will be decreased. Resistance will decrease if you increase the area. So this is the inverse relation we have. So resistance will vary inversely with the area of cross section. Now why copper and aluminium wire are usually employed for the electricity transmission? Again this is a very important and interesting question because this is a general questions from your day-to-day life. So why copper and aluminium are employed here? Copper and aluminium are generally employed because these are very good conductor of electricity. This is the basic reason. But in spite of being good conductors, they are good conductors only because they have a very low value of resistivity. So these are having a low resistivity, that's why we employed copper and aluminium wires in making the electricity transmission. So the reason behind that is our E part, copper and aluminium are good conductors of electricity. And another factor is they are having a low resistivity. So this is the reason behind that. So this is your reason type question from your chapter electricity. These questions are also very important. So these questions are over here. We have discussed some of the NCERT questions from your book here. We will deal with many more questions in our next lecture. So thank you so much and have a nice day.